Hello, welcome back to Math 8. This is a video over section 4 from Unit 7, and we're going to be talking about reflections. So our objectives today, we want to identify and describe a reflection on the coordinate plane. We want to reflect figures on the coordinate plane given the line of reflection. We want to describe a reflected figure using the line of reflection and coordinates. So remember, a reflection means that we mirror something. All right, and that's the word that we want to think about when we mirror, okay? And so lines of reflection, let's start talking about that. This is, like I like to call it the mirror line. So the mirror line, okay? And the line of reflection is between the pre-image and its image, okay? So in this picture here of this graph, here is my pre-image, and then we reflect each of these points over our line of reflection, okay? So let's write this down here that this is my line of reflection, okay? And it's mirrored, okay? As you can see, you know, in something like this where you have a, an image, how C is pointed to the left. Now over on the mirror, the C part, that coordinate is pointed to the right, all right? And so that's the idea of what a mirrored image looks like when we talk about reflections. And so the other thing that they say is a reflection reverses the orientation of the vertex points. Okay, so again, if we're pointed to the left here, then angle C would be pointed to the right, okay? So let's talk about, reflecting over the x-axis, okay? So one of the things that a line of reflection does, a reflection line is equidistant from each pre-image point in its corresponding image point, okay? And so I can show you that best here, all right? This figure shows a triangle reflected over the x-axis. So here's my x-axis, and what that does is that shows us what the line of reflection is. So I'm going to come in here, and I'm going to label this as the line of reflection or reflection line. Either way you say that, doesn't matter, but that's what I got. So what I want to do is to talk about the distance from point C to C prime, okay? And talk about the distance from C to the line of reflection as well as C prime to the line of reflection. So what I have here, C to the line of reflection is a length of 1, okay? In addition, C prime is also a length of 1 unit away from the line of reflection. Same thing with A and A prime, okay? A is 1 unit away, A prime is 1 unit away. Okay, now the one that is interesting is this one, B here, B and B prime. Now, if we're strictly just talking about the distance to the line of reflection, it's this distance here, okay? And that distance is a length of 3, okay? Same thing with B prime, that distance is a distance of 3, okay? The other thing that you can note here is that all of these lines are going to be perpendicular to the line of reflection, okay? And that's going to be the case here, and here, and here, all right? So something, just some properties that we have, okay? And so what I just showed you, in that picture was this here, all right? Now let's do the opposite. Let's reflect over the y-axis, okay? So in a reflection over the y-axis, let's take a look at that. In a reflection over the y-axis, every pre-image point is the same distance from the y-axis. So here, this is my line of reflection, okay? So my line of reflection. Okay, and so if I go from the point J to J prime, let's see what it says here. Okay, the line of reflection contains the midpoint. Okay, so if I draw these lines from one corresponding point to the other, so from J prime to J, all right, if I draw a line from K prime to K, and from L prime to L, all of these lines are going to be parallel to each other, okay? And also notice that the distance between J prime and J is a length of 4, but that the midpoint is my line of reflection, okay? Notice that this is a length of 2 and 2, 1 and 1. This is a length of 3 and 3. And that's what I'm looking at when I'm doing that, okay? And so, yes, while they are lines of, the line of reflection is a midpoint between these two, but notice that each of those points are equidistant to the line of reflection. Okay, so we don't have to just simply use the x and y axes to show lines of reflection. We can use other reflection lines. So in this, it wants us to identify the line of reflection that maps triangle ABC to triangle A prime, B prime, C prime. Okay, and I can tell that this is a mirrored image because here angle B is pointed to the left, and here B prime is pointed to the right. That's what tips me off that this is a line of reflection. Okay, it says find the midpoints of each segment connecting the preimage points to its image. Find the equation of the line connecting the midpoints. So over here, what I want to do is come in and draw in our line of reflection. Okay, so on this, what I'd want to do is come in and I just draw in a line like so, that's my line of reflection, okay? And I'm going to label this my line of reflection, okay? That's the first thing. Now, my line of reflection, we'll talk about that in a second. Let's take a look at from points A to A prime. Let's draw that line. Let's draw the point from B to B prime, and let's draw the line from C to C prime, okay? Notice that each of my midpoints are actually on my line of reflection. And let's come in here. The distance between A to the line of reflection is 1. Same thing with A prime to the line of reflection. Each of those distances are 1. From B to the line of reflection is a distance of 3. Same thing with B prime. And all I'm doing is just counting these, the spaces in between. Okay, I'm not going, I'm starting here and going 1, 2, 3. Okay, and that's how I get that. Now C to C prime is also 1. Okay, and those are my midpoints. All right, so we drew in, identify our line of reflection, check. Okay, find the midpoints of each segment connecting that, check. And find the equation of the line connecting the midpoints. So this line of reflection, remember when you have a vertical line, is simply just going to be x equals whatever number it goes through on the x-axis, okay? So in this case, x equals 2 is my line of reflection, okay, and identifying that. All right, now when we have so that's what we got, okay? All right, let's take a look at the next page. All right, so what I want to do is look at specific points of what happens when I reflect over the x-axis and then when I reflect over the y-axis. So if I reflect over the x-axis, I'm going to do that in red, okay? And that's going to be my line of reflection here, all right? So I just find my x-axis, and that's where I reflect, okay? Now, what I want you to notice is here is my original point, A, and that's going to be the point 2, 3, okay? Now, when I reflect that over the x-axis, notice that I have a length of 3 here, and this is a length of 3, okay? So it's easy to do it on a graph, but the question is what's happening as I reflect over the x-axis to my points? Here's my point 2, 3, and all of a sudden my new point is 2, negative 3. So what you want to realize is that the x value stays the same. It's the y value that changes, and that's what I want you to see here. And that the y value is the opposite, okay? So when we reflect over the x-axis, let's write down that the x value doesn't change, and the y value is the opposite, okay? And we create a rule here. And the rule is that when you take the point xy and you reflect across the x-axis, okay, what happens is that you get x comma negative y, okay? And that's the rule that we do, is that the x value doesn't change, but the y value becomes opposite. So if I had a positive y here, the reflected image had a negative y, all right? Now let's talk about the y-axis, okay? I'm going to do that in blue. So I'm going to highlight my y-axis here in blue, okay? And what I want you to see, to go from A to A prime, that's the reflection here, A is 2 units away, okay, from the line of reflection. A prime is also 2 units away from my line of reflection. Notice what happens with my point from A to A prime. This point is the point 2, 3, and this is the point negative 2, 3. So one thing that you notice is that the x values are opposites, but the y values don't change. Okay? And that's what we do when we reflect over the y-axis, is that the x values are opposite and the y values don't change. All right, so my rule that I would write for reflecting over the y-axis would simply just be x comma y. As I reflect that, would be negative x comma y. Okay, and that's the idea. All right, and we'll talk more about the rules here in a bit, but that's what I want you to see. All right, so reflecting over a vertical line. So, one thing I want to do here is take this figure ABC and reflect this over the line x equals 2. Okay, so remember x equals 2 is going to be a vertical line through 2. And so I draw this line in here as my line of reflection, and I label it as my line of reflection. Okay, and so if I'm doing this, what I want to do is take point A and figure out how far away point A is from my line of reflection, and that's a value of 4. Okay, and if I do that, I'm then just going to move this over 1, 2, 3, 4 units and plot a point, and that's A prime. Same thing with point C, that's 1 unit away. Okay, that was 4 units away. And C prime is going to be the same thing, okay, and that's going to be 1 unit away. Point B is the same. That's 1 unit away from my line of reflection, so I'm just going to reflect that over, and this is going to be B prime. All right, so as a result, then, I can draw my reflected image and just put that over on the other side, and that's how I would draw that. Okay, what about points on the line of reflection? Okay, so a point on the line of reflection will not move. So in this case, let's reflect triangle ABC over the line y equals 0, which is the same thing as the x-axis. So from here, what I'd want to do is locate all my points on there and think about how far away are they from my line of reflection. So this is 2 units. And so for point A prime, I would move over 2 units and plot that point for A prime. B prime is 2 units away, and so I would do the same thing and plot that point over here, and this is B prime. Now, because C is on my line of reflection, I can't reflect it over that line, and so it just stays where it's at. And this is also going to be C prime. And so then I connect my points and draw my triangle, and I have a reflected image across that line of reflection. And sometimes you have overlapping figures, all right? So if the line of reflection, notice here how the line of reflection goes through this figure here, triangle PRQ, okay? So the preimage and the image will overlap each other when the line of reflection cuts through the preimage, and that's what's going on here. So let's go ahead and reflect the triangle over this line, x equals 1, and we'll see what we get. Now, when I do that, I do the exact same thing that I did. I take each point on my preimage, so I'll start with point R. This is 2 units away from my line of reflection. I'm then going to go 2 units to the other side and plot my point R prime. Same thing with point Q. Point Q is 2 units away, so I'm going to then move 2 units to the other side and plot a point. and that's going to be Q prime. All right, then we have point P here. This is the weird one because now it's on the other side. I'm still going to go, well, how far away is it from my line of reflection? And it's a length of 1. So I'm then going to extend that out to the other side and plot my point P prime. And then all I do is connect my points R prime to P prime, Q prime back to R prime. And that's how we would do that, all right? And when we do this, you should know, and if I do this right, they should intersect right there. That was kind of poorly drawn. Let me come in and erase that. Okay, so you can see that, you know, when these lines cross, that these lines will intersect on that line of reflection, okay? All right, let's take a look at the last page. Okay, so we're mapping a reflection. So when we use the mapping, remember how if we're reflecting over the x-axis, that the y value changes, but not the x value. Okay, if we're reflecting over the y-axis, we use the mapping xy becomes negative xy. So the x value changes here, but not the y value. And that's what we talked about on the last page, okay? So what we want to do is use the mapping using a mapping. So triangle ABC has the coordinates A is 3, 2, B is 4, 6, and C is 1, 5, okay? If I use the mapping xy becomes x negative y, what this says is that x stays the same, x doesn't change, and that the y value is opposite. So y is opposite. Okay? And so from here, what I want to do is then I want to reflect the triangle over the x-axis, because that's what we're doing, okay? And that's the same thing that we did here. It's the same mapping, x negative y is here. And I want to reflect this image over the x-axis to find the coordinates of the image. So what I'm going to do is this. I'm going to copy down points A, B, and C. And point A is the point 3, 2, B is 4, 6, and C is 1, 5. So if I'm trying to use my mapping here, remember, x doesn't change and y is opposite. So to find the coordinates of my image, A prime is simply just going to be 3, negative 2. B prime is going to be 4, negative 6. C is going to be the point C prime, which is 1, negative 5. And look what happens. I'm not doing much, but I know my rule. And I know that my x value doesn't change, so 3 stays at 3. 2 becomes negative 2. 4 doesn't change. 6 becomes negative 6. 1 doesn't change. 5 becomes negative 5. And that's what I'm doing, okay? So you can use a graph, or you can just use your rule, okay? Okay, the last one is reflecting over the line y equals x, okay? So reflect the triangle over the line y equals x. This line y equals x here, remember this is a slope of 1. So slope is equal to 1, and your y-intercept is 0, okay? That's how we get that line y equals x, okay? And so what I want to do is each pre-image point and its corresponding image are equidistant from the reflection line. So let's physically do this and figure out what these points are. So this is a little bit harder to do, but what I want to do is go perpendicular to this line, and it's just going to reflect over and become this point, and this is A prime. B is going to reflect over that same one and be moved here, and this is B prime, okay? C is a little bit trickier. I go over 2 diagonals to get there. So I'm going to go 2 diagonals this way, and that's going to give me C prime. Now, it's hard to show what those distances are, but you kind of just have to eyeball it. So now you have this new triangle here, which show those points, okay? And that's my reflected triangle. Pretty cool, pretty nifty. So one of the things that you want to see here is, you know, and let's do this. Let's label all these points. And to show you what exactly happens, this is the point for A, is the point 2, 3, okay? C is the point -1, 3. Okay, and B is the point -1, 0. Now, let's label the points on the image. Okay, C prime is the point 3, -1. So 3, -1. B prime is the point 0, -1. And that's that. So the question is, going from one point to the next, A to A prime, B to B prime, C to C prime, what are you noticing? And what you should notice is that the X and Y values are flipped, okay? So here, I have this point here, 2, 3, and then I have 3, 2. All I'm doing is flipping those X and Y values, okay? So to reflect over the line Y equals X, we use this mapping of X, Y. This is my original point, and then this is my image, my result, okay? And you could also call this the pre-image and the image, okay? And so, but what you should notice here is that all you do from go to one side to the other is you just flip the X and Y values to get new point. All right. So from here, all right, rectangle ABCD has coordinates -1, 2, -4, 2, -4, 4, and point D is point -1, 4. And we want to use the mapping to find the image points on the triangle after we reflect over this line. So I'm going to use this rule here, okay? And so that rule is, I'm just going to write down these points. Well, let me write down my rule first so I know what I'm talking about. X, Y. After we reflect it, I'm going to get Y, comma, X. Okay, so now I'm going to take each of these points, A, B, C, and D, and I'm going to write them down. So I've got -1, 2. I've got -4, 2. I've got -4, -4. Whoop. -4, 4, and then -1, 4. Okay. And you could always plot these on a graph if you want to, but you don't have to. And what we're going to do is we're going to find the points A prime, B prime, C prime, and D prime. Okay. And all I'm going to do is switch my X and Y values. And so this is going to give me 2, -1. This is going to give me 2, -4. This is going to give me 4, -4, and this is going to give me the point 4, -1. And that's all I'm doing. And these are my points that I'm looking for. Okay, so hope you guys enjoyed this video. A lot of things that we talked about, and it's pretty cool. Let me know if you have any questions. See ya. Bye.